All right, I think we're going to go ahead and get started. There's a ton of great faces and names here, and we're so excited to have you all. Again, if you're having any technical issues, please feel free to use the chat box or the question and answer area for questions that kind of come up throughout the webcast. We'll be doing a kind of formal question and answer section at the very end, but always happy to try to answer things throughout the presentation as well. And so in the meantime, welcome everyone. We're really excited to have you for Flume's inaugural webcast. We're going to be sharing a number of key insights kind of into water use in 2020, which I'm sure is top of many folks' minds right now. We're also going to be talking about how data can and has been used to address a lot of local challenges that I know many of you faced over the last year. For those that are unfamiliar with Flume, we believe that you really can't manage what you can't measure. And since our founding, our work is really aimed to liberate water data so that we can provide real-time insights into what's actually happening in your community and in homes across the country. We decided to host this webcast because we know what a unique year 2020 was. And for many of our Texas friends, what a unique year 2021 has already been. So we're really excited to have you all. We really hope that this information is useful and that it can be of value. And if there's more that you're interested in, or if there's more that we can provide, please feel free to reach out. In the meantime, let's go ahead and get started. I'm Sarah Musiker. I'm the Director of Utility Relations at Flume, and I'll be generally emceeing this webcast. And I'm joined by a number of incredible panelists who you'll get the chance to hear from, mostly from them, less from me, which is always good for everyone. Let me start with Peter Mayer, founder of Water DM. He is, of course, the kind of king of end-use studies, and we'll be diving into a lot of that soon. We have Karen Guz, Director of Conservation for San Antonio Water Systems. We're so very grateful to have her, considering the amount of work that she's been doing over the past couple of weeks, as I'm sure we're all aware. And then we have a few folks from Flume on this call. So Flume is, of course, the company. And so we have James Fazio, our Chief Technology Officer and one of our original founders, who is here to answer all of your technical questions and talk about kind of the technical piece of the work that we're doing. Joe Fazio, who is our VP of Customer Success and Data Insights. So if you've ever run a program with Flume, or if you are interested in kind of looking into some of this data, he's going to be your go-to person. And then there's me. As I mentioned, Director of Utility Programs, and we're so excited to be here with you all today. Very quickly, I'll just kind of give you an overview of what we're actually going to be doing. I know that's a lot of Flume folks, but we're hoping to cover a lot of information, and so I'm just going to go ahead and hopefully dive right in. As I mentioned, kind of the sole goal of this presentation is just to provide information and kind of accurate insight into water use in 2020. We have data on a number of places across the country due to the spread of Flume kind of in a number of communities. And we can show a map kind of at the end of this presentation, as well as we're going to kind of explore how we collect this data, how we analyze it, and then how it has been utilized and can continue to be utilized across communities. And so I'm going to kick things off with a quick overview of exactly what Flume is. I promise to keep this short. Just it's helpful to have a shared understanding of exactly how Flume captures this data. We actually have tens of thousands of devices across the country, and we'll be providing a coverage map kind of at the end so you can get a sense of where Flumes are in your community and what's really happening there. I will then be introducing Peter, a man who needs no introduction, really the king of end-use studies, as I already mentioned, and he'll be sharing some insight into kind of traditional data collection methods and the ways that these have grown over time. James will then be diving into exactly what our data looks like and how we collect it and how we kind of analyze it down to the 5-second marker and why that really matters, how it's been able to help us unstack water use between indoor and outdoor and just really look at water use overall. Following that, Joe and Peter will be sharing a number of graphs and various analysis based off of this information. We'll be looking at indoor and outdoor GPCD for 2020, water use changes as a result of COVID and that really serious COVID spike, and a number of other insights. Finally, we'll be rounding out the presentation with Karen, who will present on some really key insights into Texas water use and how SAWS has been using these insights to really plan for future water demands and address a number of local issues in their community. And at the end, as I mentioned, we'll have time for Q&A, and I'll also be kind of sharing this map of kind of where we have Flume devices for those that are curious. But in the meantime, please use that question and answer box, as I mentioned, and hopefully it will make it of great value to you throughout the presentation. So what is Flume? Flume was founded in 2015 in California in the middle of our record drought. We were actually founded by two engineers who were hearing all of this messaging from their utility about the importance of saving water, and they agreed, and they really wanted to do what they could. But they often didn't feel like they had an understanding of exactly where their water was going or how they were using it or how they could improve their use. And so being engineers and kind of being curious folk, they developed a device that would help them kind of give those insights. And we've really just grown from there. So it all starts with this sensor. This sensor actually hugs the water meter. It is self-installed by homeowners in under 10 minutes. So it's pretty simple. You can see the strap kind of right here that kind of helps it to hug the water meter. It's a rubber strap. And this plug and play system really is basically the second you have it on the device, it brings all this information online. It immediately begins measuring water use every 5 seconds. This device, and just for heads up for everyone, is really intended for single family residences. There's a number of great technology that kind of can work with large commercial entities or multifamily units. We really do focus on the single family water or single family residence water use because we feel like that is a really valuable area of insight for many communities across the US. As I mentioned, though, once it's installed, it shares that information with the Wi-Fi bridge through an RF signal and takes that information immediately online. And we provide a software, we provide software as well. It's available both on cell phones and on desktop. And the second that the device is installed, people are immediately getting insight into their water use. This basically allows people to immediately understand exactly where there's water is going, and perhaps more importantly, create resulting actions that really help them to improve their water use over time. It helps them to understand where leaks may be. It helps them to understand, oh, maybe my bill really was this high last year because I used this much water, versus there's no way, you know, I'm sure you all have gotten a call saying, there's no way I used this much water last year. Well, we help to kind of address some of those challenges. We provide really the unique insights for customers and utilities alike. As I mentioned, we've got a software application that is available for customers on cell phones and smartphones, but we also provide insights to utilities through a dashboard where they have access to this exact same information at both the customer specific and then the aggregated level across their community. So for the customer benefits, you can see some of these listed right here. Real-time monitoring really allows people to understand exactly where their water is going. We are able to separate indoor and outdoor use. As I mentioned, James will be kind of explaining how and why we're able to do this. So we can separate out irrigation versus indoor water usage. We're really excited that later this year, we're actually going to be launching an update that will be pushed out to all current devices, all current Flume 2 devices that basically allow for separation even of appliance and fixture indoor water use. So we'll be able to get that specific. This all allows for people to have a really almost immediate insight into potential leaks in their home. And this has been one of the greatest benefits, we think, for customers who prior to this may only find out about a leak when it shows up on their water bill, or perhaps when it later causes some pretty extensive property damage. I think Karen may mention this, but when obviously the freezes happened in Texas and a lot of leaks kind of resulted from that, we were really able to notify folks immediately of potential leaks in their community. We also provide for water budgeting, which can make a real benefit as well for communities that are either under drought restrictions or customers that are trying to save water or save money. We provide them with immediate insights into how much water they're actually using, and it allows them to budget. And lastly, before I turn it off, I just want to talk about some of the utility benefits we provide. We work really closely with utilities. We obviously work directly with customers, but utilities really are the backbone of how our water systems work across the country. And it is our sole goal to ensure that we are working with them in positive ways to help them achieve local benefits and address local issues. And so we do this through efficiency programming, if that's of a local need or local concern. We provide unique customer service benefits. And we also provide a lot of insights, as I mentioned, through this unique dashboard that really allow us to help utilities interact with their customers in new ways, improve customer service benefits, and really achieve ultimate goals in in whatever way is necessary for that local utility. And we'll be talking about that a little bit more soon. And so with that, let's dive into the real stuff and the really good stuff. So we're first going to be chatting about end use studies, and I want to remind everyone to use the question and answer function as necessary. I see someone who already has, so that's great. But first, let me introduce Peter Mayer. He's the principal of Water DM and a strategic partner of Flume. Over his career, he has worked on with hundreds of water utilities and organizations across the US and Canada as an end use research expert. So with that, I'll turn it over to you, Peter.
Well, thank you so much, Sarah. And hello, everyone. Thank you so much for joining us today. It's really a great pleasure to be able to talk to you and to present really some remarkable data. But first, I wanted to put things in context. So let's go to the next slide. And I wanted to start off with a poll. I was curious how many people are familiar with the residential end uses of water studies. And maybe let's find out how many people have actually accessed them or used them. So let's launch the poll. And then I wanted to really give a little bit of the history. I've been working on studying water use for almost 30 years now. And our understanding of water use started with monthly data in the most simplest form is a little bit like this chart, which would represent indoor and outdoor use at a single family home, or even perhaps if you could scale it up at a utility in a climate where there is winter, essentially no outdoor use in the wintertime. And prior to high resolution data, this was the best data that we had. Okay, so here are the results. So we had 63% of the folks are familiar, another 8% are familiar. We have 18% have never heard of them. So check those studies out. And anyway, great, thanks so much. So the key breakthrough for end use studies was in the early 1990s with the development of data loggers and then signal processing software for disaggregation. And so this is a picture of one of the data loggers attached in a meter pit that we used for the first two residential end uses of water studies. All right, let's go to the next slide. So this is a brief history of previous end use studies that I've worked on. There have been a few other ones conducted and a number of other studies conducted elsewhere around the world. These were studies that were conducted largely in the US and somewhat in Canada. But starting in 1995, that was a study that was part of my master's research. And then moving into the residential end uses of water studies in 1999 and all the way through 2016, you could see that the largest sample size that we ever had for an end use study was 1,188. And typically the largest duration of time that we were able to measure end use data for was 4 weeks. And 4 weeks would always be broken up into 2-week chunks. You'd have 2 weeks at one period and then another 2 weeks. And that was the limitation of the data collection devices. All right, so let's go to the next slide. And so just to give you an idea of what you're going to be seeing today compared with those studies, so Karen Guz will be presenting data from San Antonio, Texas later in this presentation that includes more than 7,000 households. So that is more households than all of the other end-use studies combined. So it's just in terms of the sheer numbers, we're dealing with something that is substantially different. Okay, next slide, please. So I truly view this as a significant advance in water use research. And just for comparison, this chart shows you how Flume can visualize indoor monthly water use. Think about that first chart, where we just basically think of indoor water use as a flat line. It's the same every month. This is average monthly indoor use in California across 2020. And it shows you the range and diversity of indoor use that occurred through the year, particularly in April. We're going to be diving into this, but this is just a little bit of a taste of the level and nuance that's available. So the key advances are much larger sample sizes. It's going to be much less expensive to collect data because it's a homeowner purchased and installed item. This is a device then that collects data continuously for 5 seconds without any time limit. And furthermore, you can also go back and analyze data retrospectively. So, if you want to take a look at something that happened in the past, as long as you have that data, it's absolutely possible. And so The other thing that's significant about it is that data failures have been eliminated because the device itself stores data. If there's ever a communication interruption, it will send the data once communication has been reestablished. That was a tremendous Achilles heel of the end use studies that we worked on in the past. Often we'd go and find that a data logger had failed and we'd lost all of the data. And so that's just no longer going to be a problem. So we're going to today show you indoor and outdoor disaggregation, and also we'll look at some peak use. Stay tuned, the end use is coming, and that's very exciting. But there's also a variety of other analyses that these data are going to be used for understanding leakage and how much flow passes through the meter at low flows. What about high flows? I've already looked at data that shows occasionally flows are exceeding the rated capacities of the water meter, particularly during some irrigation events. So there's going to be, I think, new data on peak capacity as well. And I think we're just scratching the surface. This is really just the beginning. So with that, I want to hand it over to one of the brilliant engineers that founded Flume, James Fazio.
Thank you so much, Peter, and thanks, Sarah, for giving a great overview of what Flume does. So Flume over the years has gotten really good at collecting water usage data. Where it starts to get really interesting is when you start to apply some machine learning to this data. And that's where we can start to get all these cool insights that Peter's talking about. Currently at Flume, we're already utilizing machine learning for a number of things. We use it for our leak detection. And what we do there is we filter out common events that are long lasting. So if a user has a water softener, that lasts more than 2 hours, or an irrigation event that could typically last for 2 to 4 hours, those all get filtered out so the user is not constantly alerted of something that's normal as a leak. We also utilize machine learning currently to allow users to check their meter compatibility. So all they have to do is actually take a picture of their meter. We use image recognition to figure out what that meter is and tell them if they're good to go or not. The focus of this presentation is around indoor and outdoor disaggregation, and this is something that we're already doing today. I'm going to spend a bit more time talking about that. In the future, we are looking at doing full appliance disaggregation. So that means eventually one day we'll be able to tell you what was your clothes washer versus your dishwasher versus your sprinkler system, and all that comes with that. And eventually too, doing more of contextual disaggregation. So sort of learning the habits of a home and being able to do a lot better job at anomaly detection and being able to detect very quickly if something is out of whack. Sarah, you can go to the next slide. So obviously our data set is all the water usage that we're collecting out in the field. So how do we actually go about labeling this data as indoor versus outdoor usage? So we have 3 key ways to help us label. The first one is we have a partnership with a smart irrigation controller company. So we're able to get all of this ground truth data with our customers that have these smart irrigation controllers. This self-labels all the irrigation events for those customers, which is a great data set for these automated sprinkler systems. We also do some hand labeling via experts. We work with a firm in Australia that's worked with DWR before to help try and figure out how to disaggregate water use. We also have other experts out in the field that help us hand label that have been super helpful for Flume. And the third thing that we do is we use user provided information. So in the app today, we disaggregate indoor versus outdoor. We get lots of feedback from our customer base saying, hey, this wasn't my irrigation vent, or this was my irrigation vent. This is what it actually was. We use all this information together to help enhance our data set. And we continue to build upon this every single day. And Sarah, you can go to the next slide. So what actually happens is when a water usage event comes into Flume, we look at all these sort of event statistics about that water usage event. So we look at the amount of time it was running for, the time of day it was running for, how much flow happened during that event, the diversity of that flow. With all of this, we apply some rules, and at the end of that comes a label that says this is indoor or outdoor. This is a very similar method that we'll be applying to do full appliance disaggregation, but this is what we're already doing today with indoor versus outdoor. You can go on to the next slide, Sarah. So I want to show you a really cool graph. What this is each horizontal axis is a day of water use. So this is an entire month for a home. The vertical axis is actually the flow rate of each of these events. So you can kind of see all throughout the day, there's scattered events. And then there's also these events that seem to happen more consistently. So Sarah, if you go to the next slide. This is after the Flume machine learning has gone through the data and labeled irrigation events. So you can see at this house, there's a very consistent timed irrigation cycle that happens every single morning. And you can see there was actually one manual irrigation event that happened later in the day for this particular user. And that means the rest of this usage is typical indoor use. So it could be anything: showers, toilets, water softeners, etc. And I want to show you another example. So here's another user. It looks like they use way less water, during the night than they do at the day. There's a very clear delineation here. And then Sarah, if you go to the next slide, this is also after Flume machine learning has gone through the data. So you can see this user has irrigation both in the morning and in the nighttime. We can also see that at night, there's this water softener event that also seems to have sort of that kind of fixed schedule. So very interesting to take a look at this data. Sarah, you can go to the next slide. This is just me poking around a user's house. The green represents irrigation. The blue represents indoor use. So you can see for this particular user, they also have irrigation that happens in the morning and at night, where that sort of normal usage happens during the day, which is all indoor. And Sarah, you can go to the next slide. So the great data is key here. The great thing about Flume is we capture water at the source. So we are able to, for any home that we're installed, we are able to capture both that indoor and outdoor usage and have, the entire picture there. And Sarah, if you could go to the next slide. And what we've done with the 1 minute data has been pretty amazing. That's where we can do this indoor versus outdoor delineation. But the 5 second data is where this truly becomes game changing. This is where we can actually start to look at events at a very granular level and start to do that appliance disaggregation. So I want to show you some examples that really put this into perspective. You can go to the next slide, Sarah. This is 3 hours of data. So 2 a.m., 3 a.m., 4 a.m. You can see, at the hour level, I don't know if this is a leak. I don't know if this was someone that was flushing the toilet throughout the night. I have no idea what's going on here. If we go to the next slide, it shows it at the minute level. Okay, I can start to see maybe this was a few toilet flushes. Maybe it was some event. I'm still not really sure, but it definitely paints a better picture. And then if we go down to the 5 second data, which is on the next slide, I can actually see 6 clear events that are attached. So this is actually a clothes washer that's going through 6 cycles. It's pretty amazing to see like how consistent those cycles are and how spaced out they are and still being attached to that one event. I want to show you one more example too. So here's here's at the hour. We have 6 p.m. and 7 p.m. It looks like 90 gallons at 6 p.m. and then about 50 gallons at 7 p.m. I don't know what's going on here. If we go down to the minute level, it definitely does a better job. I can see this, looks like some sort of irrigation event, but it also looks like there may be something else at the beginning. And if we go down to the 5 second data, boom, very clear. This is an irrigation event that's, happening around, looks like 6:30 there. But in the background, there's actually a dishwasher going on. So that dishwasher actually starts before the irrigation, and then it actually goes through the irrigation and out on the other side. So this is where, it starts to get pretty amazing and shows the potential of what's to come in the future. I wanted to keep this short and sweet, not get too into the details of how we do the machine learning. And now for the really interesting stuff, I'd like to pass it back to Joe and Peter that are going to show you some graphs from 2021.
Great, thanks, James. So I want to start out with just a little background. James talked to you a little bit about the machine learning work we've been doing. But really, we started doing this machine learning last year, and kind of the first big task that engineering went through was to go through and do all of that labeling of the indoor versus outdoor water use events. And they basically did that for all past events, as well as now anytime water is used, that data is labeled automatically. And then basically in October of 2020 last year, we made that data available to our customers through our app. So they were able to kind of monitor their own indoor and outdoor water use. And then in December, we started to extract that data kind of in aggregate. So we started like extracting all of the water use data from a city or a state. And that was really the first time that we started to really look at that data in aggregate and put it onto a graph. And I don't want to speak for Peter, but I think we were both just shocked at some of the data once we actually graphed it. It was pretty amazing stuff. So those are some of the graphs that we want to share with you today. So let me get right into it. So Sarah, if you go to the next slide. So this was one of the very first graphs that Peter and I looked at and just said, wow. So Peter teased this graph a little bit in his introduction, but this gives you a little bit more data. What we're looking at here is indoor water use, and specifically indoor per capita water use for California all throughout 2020. And what you'll see here is that, you know, around the beginning of the year, we're kind of staying in this band here, trying to draw here on this. We're kind of staying in this 50 to 55 gallon per person per day type of band, which is kind of what you would expect in California. And those are kind of the guidelines in California. But everything starts to go haywire here in April, and I'll let Peter kind of talk to that.
Well, you know, it goes kind of to our historical understanding of indoor use, which we always thought was flat throughout the year, or maybe with some seasonal variation. But the Flume data has revealed not only the COVID thing is one thing, but then also other variations. So what happens in April is the COVID lockdown and stay at home, and you know, people did not go to work. They flushed more. They used more water indoors. It's an unprecedented indoor water use event, is all I can say. What's interesting, though, is that demand doesn't go back down. It continues, it stays elevated at around 65 GPCD, and only later in the summer does it start to go back down slowly. And so this, of course, led me to ask Joe, well, you got any data from 2019?
Well, funny you should ask, Peter. Sarah, if you go to the next slide. What we did here is we actually overlaid that 2019 data on top of 2020. Now, just one caveat here. For 2020, we had about close to 7,000 devices that we analyzed in California for the 2020 data. 2019, we didn't have quite as many, but still very, very representative sample set. It was in the thousands. But we did map these two against each other, and this is what we found. So Peter, why don't you give you some analysis?
So let's look at 2019, which is the aqua blue or Miami blue color. And there, you know, you could see absolutely water use was lower by and large, but it does vary throughout the year. There are significant little blips of indoor use. And, you know, we haven't looked at this in great detail, but many of them appear associated with holidays, spring break, weekends, particular events during the year where, you know, large numbers of people are changing their water use patterns. But that's something we're going to be looking at, you know, into the future. But in terms of the difference between the 2 years, I think it's pretty clear. I mean, you could see that demand starts about the same. It diverges dramatically as a result of COVID. And then is it coming back to about the same level? Perhaps. That's really the million-dollar question as we move into 2021. Are we seeing new behavior patterns, or are we going to eventually return to something that resembled the past?
Yeah, we're starting to just look at the first quarter of 2021. So stay tuned, because we'll have some data on that as we exit March, and we'll be publishing some of that data as well, because we're very, very curious to see if that gap closes or not, or if we just have a new normal. Maybe 50 to 55 was normal for California before, and maybe 55 to 60 is our new normal going forward. I don't know. So we hope to find that out. All right, Sarah, if we go to the next slide, what we're looking at here is basically what we were just looking at, which is a comparison of 2019 and 2020 water use. But instead of looking at California, we're actually looking at Texas here. And I think what's pretty amazing is this Texas 2020 curve is very, very similar to California, and also the divergence that we see here in the April timeframe is similar as well.
Right. Yeah, I mean, very similar baseline, essentially indoor GPCD, and then you see the impacts of COVID. And the swings in Texas are substantial. The initial bump up in April is perhaps not as large as California, but then there's other substantial swings as other policies were put into place and people responded throughout the year. And then finally, though, they end up right about where they started from.
Yeah, unlike California, it looks like we've kind of converged back to quote unquote normal here in Texas, whereas in California, not quite yet. So yeah. Again, it'll be interesting to see in the first quarter of 2021 whether or not California converges again. Sarah, next slide, please. So now I've taken this to the logical progression now and just compared California versus Texas. And as I just said, these curve shapes are extremely similar. The magnitude of perhaps the April response is very different, but overall the shapes are pretty similar.
Yeah, and I mean, there's a few points where they go against each other, but many times, you know, the curves are moving together in response to similar orders and policies that were put into place throughout the year. But of course, you know, the April is this extraordinary occurrence of an increase in indoor water use.
Got it. Interesting too to note that you know, the GPCD in Texas is pretty low. You know, in fact, it's lower than California through a lot of this kind of COVID lockdown, which is pretty interesting.
Somebody asked about how many devices were in Texas, Joe. Is it about 10,000?
Yeah, I think this sample set was, I want to say it was 7,500 or 7,600, some in that range. Yeah, so pretty big samples. Actually, I take that back. The Texas sample size is over 10,000. Sarah, if you can go to the next slide, please. So let's switch gears now and look at some outdoor use, because I think this is equally fascinating. For this first curve, what we're looking at is outdoor household use. So we've switched gears. Indoor, we typically look at per capita use. And for outdoor, we're switching over to just household use. We think that makes a little more sense to look at that. And what we're looking at is outdoor household use for 2020. And we're comparing 3 different states here because I just thought this was fascinating. The blue curve is California, so the biggest use. The brown curve is Texas, and then the green curve is Georgia. Obviously, very different irrigation use and also very different weather patterns in each of these 3 different areas.
Yeah, I mean, this is really the story of 3 regions and 3 climates. So let's start with Georgia. So Georgia, first of all, I had the privilege of working for the state of Georgia as their expert at the U.S. Supreme Court, and so I'm quite familiar with their water use patterns in the urban areas, and they really do have extremely low water use. And your automatic clock-driven irrigation is much less common than it is in the Western United States. Manual irrigation, and often people don't irrigate at all. And that is really what you're seeing in Georgia. But at the same time, you also are seeing some responses to climate events, but perhaps not as exciting as the responses that are occurring in Texas. The Texas curve is remarkable because of the dramatic ups and downs. Those are in direct response to precipitation events, and then later in the summer in direct response to a call from the utility to cease irrigation, and Karen Guz will be talking about that and showing how that worked. And then finally, the California curve. I mean, the most significant shift that you see that occurs in March, and that's where they actually did have some rain. most of the story of 2020 in California was, and a lot of these data come from Southern California, there was not a lot of precipitation. And so what happens really starting in April is use goes up, and it never really comes back down until the weather cools down. The other thing that's significant is there's irrigation that's occurring pretty much all months of the year at some level, particularly in California.
Yeah, and Karen from SAWS is going to go into this in a little more detail, and she's going to actually compare her particular outdoor curve, which looks similar to the Texas curve, and compare it to weather. So this will tease that a little bit. Sarah, if you could go to the next slide, please. You mentioned, Peter, that Georgia, they don't tend to irrigate very much. This is a chart. When people install flumes, we ask them lots of questions about their home. How many residents do you have? Do you have a pool? How many bathrooms do you have? And one of the questions we ask them is how often do you irrigate? Over 50% of the people in Georgia told us they didn't irrigate. That would explain, obviously, why their outdoor usage is so low. And Sarah, if we go to the next slide, we asked the same question of all of our users. So this is just the California responses. Over 50% of the people in California irrigate, or over 40% of the people in California irrigate 4 or more times a week. So it's almost the inverse of what's going on in Georgia. Less than 10% of the people in California don't irrigate. So again, that can very much explain the differences between California and Georgia in that last slide.
We also got some feedback that it was a very wet year in Georgia in 2020.
And a very dry year in California.
Yeah.
So it all makes sense. All right, Sarah, if you could go to the next slide, that'd be great. This, to me, is one of the most fascinating slides. In blue, what we have here is an outdoor household curve for 2020 for a water district that's in Riverside County in California. And it looks very similar to the California curve, which is there were a couple rain events here in March and April. So you see, these kind of dips in the curve. But right after April, it didn't really rain at all until the winter. So you have this giant mountain that comes up and then comes back down as the weather gets cooler. But what we did is we overlaid the reference ET on top of this curve. And I think, Peter, you and I are both blown away just by the correlation here between these two curves.
This is truly amazing. So for people who aren't familiar, ET stands for evapotranspiration, and that is the water requirement for plants to grow. And it's a very good measurement of how much water is reasonable to use outdoors. I don't know that I've ever seen a dance between outdoor water use and ET like this chart, where they really just move together. And the responsiveness of people to climate changes is truly phenomenal. And particularly look in the beginning of November, and where they're like in lockstep almost at that point. So there's a lot of additional analysis that can be done looking at specific events and who's responding and who's not. But overall, I think the message that we're seeing from 3 different states is that water users are by and large quite responsive to changes in the climate.
Yeah, definitely. And Karen's actually going to dive into that a little more as well. And even look at how responsive people with smart irrigation controllers are versus the general population. And I think that's pretty fascinating as well. So stay tuned for that in a few slides. Go ahead to the next slide, please, Sarah. Here's another really interesting graph. And this is a water district that's in Nevada. And they have watering restrictions in Nevada. And one of the watering restrictions is that people can't water on Sunday. So what we did is we took a look at all the Sundays in 2020, all the Mondays in 2020, et cetera, and kind of came up with the average for each of those days of the week. And by and large, people are following the water restrictions there, which is great news. And I think it goes to show that water restrictions actually have an impact and people generally follow them. I mean, we see, people water about 25% as much on a Sunday as they do on a Monday. And they've actually pretty evenly spaced it out during the week here too, which is interesting.
Yeah. I mean, this is never on Sunday, and it appears to be working.
Yeah, definitely. Sarah, next slide, please. Now we just looked at by day of the week, but now let's look at by hour. We did something similar with the day of the week here, which is we looked at every Sunday at midnight for all of 2020, and then every 1 o'clock at Sunday for 2020, and kind of took the average across the entire year and came up with usage by hour. And again, we're looking at outdoor use still. And I think what's really fascinating about this curve is that, and this happens to be actually, this is San Antonio, and pretty fascinating. They have drought restrictions there as well. And one of the rules with the drought restrictions is that you can't water on Saturdays and Sundays. So if you look at the peaks of these curves on a Sunday and you look at this peak of this curve on a Saturday, they're much lower than every other day of the week. Also, it turns out that with the SAWS drought restrictions, more people fall into the Monday bucket than do fall into the Tuesday, Wednesday, Thursday, Friday bucket. And you'll see here that, you know, the peaks are a little larger on Monday, as you would expect. But fascinating that also that people tend to water mostly pretty much at 6 or 7 a.m. every morning, and then 8 p.m. at evening pretty consistently.
Yeah, I mean, I think this is evidence of clock-driven irrigation. The peaks are so consistent and consistent. And it also gives you a sense that if a utility needed to shift demand, this would be a way to look at it. You can see where the troughs are occurring, and you know, it's not hard to envision some form of load shifting if that were a requirement.
Yeah, definitely. And I think too, one of the rules in SAWS is that you have to water after 7 p.m. at night. And you see here that people tend to water at 8 p.m. So
yeah, they're starting right up when they can.
Yeah. And again, I mean, drought restrictions actually seem to work and people seem to follow the rules, which is interesting.
Yep.
All right, next slide, please, Sarah. And finally, I took that exact same graph we just looked at, but now I've overlaid the indoor use and then the total use from SAWS. And again, we're looking at it by hour. And I think what's interesting about this curve is that the indoor use and the outdoor use tend to be very coincident, which as Peter, you were just talking about a little bit of peak shaping. Do you want to comment on that a little bit further?
Yeah, well, so this is really the diurnal curve of water demand throughout 2020 in San Antonio. And what's important for utilities is your single family demand is often what's driving the peaks if that's your largest sector. So this sort of picks it apart and shows where that water use is. It's quite significant to think about. You know, if you had a peak constraint at a water utility, it might be a lot less expensive just to shift the timing of irrigation rather than to construct a new facility.
Yeah, definitely. Well, great. Sarah, do you want to go to the next slide? So that's all that Peter and I have. And actually, Karen is going to dive into some more data that's very SAWS specific and show you some even more interesting graphs. But before I hand it over to her, I just wanted to introduce Karen as if she needs an introduction. I think pretty much in the utility world knows Karen. She's kind of one of the superstars.
Right in the middle of your introduction, Karen.
I think you froze up, Joe. So that shows that people don't really need to hear about me. I can just talk.
I wasn't done giving you some your laudatory introduction here. I wanted to say, and I think this is a fascinating piece of information about you, that you save SAWS over 1 billion gallons of water per year, which I think that's pretty significant. So pretty great achievement. So with that, I will hand it over to you, Karen, and let you get into your presentation.
Okay, thanks. So I was tasked to talk about how we put the data to work at San Antonio Water System. And Sarah, if you can go to the next slide, I put this into really 3 things that address why SAWS has been pretty enthusiastic about the Flume product and why we think our customers like it so much. we started out really being interested, of course, from a perspective of conservation programs and saving water. And then we started diving into really interesting questions that the Flume data could help us answer around planning, forecasting, and program evaluation. And then I'm also going to get into a little bit how it's become really a customer relationship program as well. So let's go to the next slide and start with the conservation questions. You know, when something new comes along, those of us in the water conservation field are asking the question, well, is this going to work? You know, here's a new product to the market, something new that can maybe help our customers save water. Should we incentivize it? Will the customers even want it? So we started a pilot program a couple of years ago to try to answer those two questions. And we wanted to know, of course, you know, will the customers even go for this if we do a pilot? And if it's going to save water, can we get a handle on how much? So let's go to the next slide. So we looked at the product and talked to Flume about getting a special site for doing our pilot and promoting it to a subset of our customers, and started asking that question. Let's go to the next slide. And in our random control trial that we did for almost a year, the savings question you're probably wondering about was a really clear initial savings. We had two groups, a control group and an intervention group. And we could really see that in the first couple of months, there was a clear drop in the Flume group. Now, I will tell you that as we look at the two groups over time, it's not clear how much the savings are retained or not, and what's really going on with the Flume users. So we're excited that in 2021, we're going to be diving more into what exactly drove the drop in the first couple months after people got the Flume, and what changes as they have it for longer. Is it that it's mostly behavioral, they're playing with it and paying a lot of attention, they all tell us they're finding leaks, they all believe they're saving a lot of water? So we think we're saving, but we want to really make sure we're maximizing the retention of that savings over time by understanding it better. On the issue of, do customers want this thing? Oh, yes, resounding yes. Customers were really enthusiastic. We had no trouble recruiting people into the pilot. And then you can tell from our numbers that people continue to use this program at a high rate in San Antonio. But I want to pivot to now talking about kind of interesting questions. Once we started getting this data, my team, they're curious people, started asking all these questions. Let's go to the next slide. And frankly, as we started looking at where these are and how many we've got, I got to a point where I wondered if Joe was going to stop returning our phone calls because we kept asking more questions of the Flume software team. But before I get into that, I do want to give you a big caveat in San Antonio about how this is different from the residential end use study. When we were part of the last residential end use study, it was scientifically deployed to ensure that even though it was a limited sample size, we had really all parts of San Antonio represented, different kinds of households. And this is not what's going on with this program. This is people choosing to use it. And it's not a surprise, given that it's discretionary, it's technology, it's fun. 94% of the Flumes in San Antonio are in these red zip codes that you see. And it tracks these parts of town. If you knew San Antonio, you'd say, okay, I know that demographic who lives in those areas. They tend to be more affluent, little higher users, more likely to have an irrigation system. Those are the types of customers who are highly attracted to Flume. We have some in other parts of San Antonio, but they dominate in this part of San Antonio. So we're very aware that it's not a scientific sample at this time. Let's go to the next slide. We also asked the question about home age to say, well, you know, we get a sense of how old the average home is in San Antonio. What's it look like in people who are attracted to Flume? You can see on this that newer homeowners, people in newer homes, tend to be very attracted to getting a Flume device. We got a few of those 100-year-old homes in there, but not as many as are represented in our community. So that's of interest. And then the last one I'm going to show on this is a home value, I think. Let's go to that next slide. When we look at water use patterns in San Antonio, home value generally has a really strong correlation with overall single family residential use. So we were very curious about the type of home value we were going to see. And not surprising, it skews more expensive, that people who live in a more expensive home are more likely to buy the Flume and be very interested in it. And so again, we're just aware that as we go into 2021, we are making an active effort to frankly give it away free and push to get it in some of the lower income homes and the older homes, so that as we look at some of the questions I'm going to bring up, we have a better sense of proportion to these questions across our service area. So let's go to the next slide. So in the questions that we started asking, we realized we have information we've never had before. We could look at monthly use by month, but we could never say by day what was happening indoor versus outdoor. We also have this access to people being willing to answer all kinds of questions when they set up their Flume. We know how many people are in that house. We know all kinds of discretionary use devices, some of which we can tell from other data, but they tell us, I got a water softener, I got a pool, I got an automatic irrigation system. Here's how often I use the irrigation. So they answer all these detailed questions. And so now when we're trying to figure something out, it's a heck of a lot easier. So I'll give you a couple examples. Let's go to the next slide. So one weird question we posed to Flume was about water softeners. We have very hard water, primarily groundwater in San Antonio. And so water softeners are pretty popular, especially among more affluent customers. And we know they are associated with an increased indoor use. And frankly, we're considering a program related to them, and especially in a part of our service area where the water is now softer, that maybe we could entice people to retire their water softener. But we wanted to get a sense of how many are out there. We had no idea. You don't have to have a permit to get a water softener. So we were taking a guess. We were also running estimates as to how much water we think people use from their water softener. So we challenged the Flume software engineers to discern how many are there. And they did a variety of things that they ground truth by asking the customers, did we get it right? Do you have a water softener? Yes or no? And so it looks like among Flume users, which I told you track more affluent, 80% of those customers have a water softener. That's a lot. That's more than we guessed. And when we look then at how often are they recharging, because the regeneration cycles determine how much water they use. Sometimes they go haywire and recharge constantly. We're running about 250 gallons a month on the average water softener. So great information as we contemplate a program and try to talk to our customers about their water softener and how they're using it. So let's go to the next kind of question we asked. Next slide. So another thing that came up pretty recently, again, is that SAWS is going through a wastewater master plan update. We do water and wastewater. And you see here a map of our sewer sheds and some sewer infrastructure. And the folks who run our wastewater system are always coming back to me and saying, why is our effluent not going up? We keep adding more customers and we should be adding more sewage. Why have we been baseline not changed for 20 years in the amount of sewage we treat? This is weird. And the answer has been because we keep reducing the indoor per capita. And they keep saying, well, you're done with that, right? You're at the floor. You can't get any more efficient. I have argued no for years, but now with this indoor per capita data broken down, often we can break it down by all kinds of information like how old the home is. The answer is a clear no, we're not done. Sorry, guys. Yes, you're going to keep seeing that wastewater flow not go up for a while because we are not at the floor, anywhere close to the floor of what indoor per capita could be. We're lower than we used to be, but we got a ways to go. So key information as they're modeling how much capacity they think they need to add to the wastewater treatment. Next slide. So other questions we're looking at, we are tasked also with doing demand forecasting. About every 5 years, we redo that at SAWS. And we of course look at a lot of demographic data. We look at how much water people use by household, age of household, how old the home is. but we're never able to so clearly break it out and look at outdoor before. And a key planning thing for us is that peak. How much are we going to use in a hot, dry summer in San Antonio? So it matters a lot what's happening at newer homes. So we asked the question, how's the outdoor use per household per day go by home age? Now, I won't go into the details of the ups and downs on this, but we can see a pattern in when in the 1990s we started getting more irrigation systems with homes as they're being built. Then we can see the effect of code coming in and improving those irrigation systems. They're really common with almost all new homes now, but the lots are smaller and the irrigation systems are better, and we can see that impact. So that's very interesting to us. Let's go to the next slide. We also asked the question about that home value. We've analyzed it before for total home use, and we could see a clear trend. But wow, you can really see it on the outdoor use. There is this clear relationship between value of home and how much water people use. It's not just lot size. Lot size matters, and we can see that in other data, but especially when we look across our whole system and not just these type of customers, the correlation on lot size kind of breaks down. But the combination of all the data we have, now we can take a look at as new homes are coming into our service area. It does matter a lot. The impact of a $300,000 house is a heck of a lot more on peaking than a $200,000 house is going to be. So that's going to mean a lot to our forecasting as a system, and frankly, our infrastructure plan on the water and the wastewater side. Let's go to the next slide. So this just looks at that relationship in an even more clear way, where you can say, here's the outdoor household per capita per day by home value. And you can see this very linear relationship as the home value goes up to help us make a suggestion of how much more impactful those very expensive homes are versus the less expensive home, and kind of put a number on it. Let's go to the next slide. So here's a program question we asked. We mentioned that they showed you some slides showing responsiveness to weather. Well, we've always known, we can see it in our total production data, that rain matters a lot in San Antonio. And these blue bars that you see, I apologize if the x-axis got cut off at the bottom, the blue bars are rain events. So one key thing that we've always sensed, but this made really clear, is that to be significant, a rain event has to be a ½ inch. If it's more, great, but the under ½ inch rain events don't matter so much. But you can really see the dips in consumption on outdoor with the rain events. And we wanted to know if households that have smart controllers were more responsive to weather or less responsive than households without them. So the light blue are all the households that have a Flume, and then the green were ones that have a smart controller. We know they have it because we incentivized it or they were part of our pilot. Now, I don't get tied up here on the fact that the smart controller homes use more water. I think that's other issues. That's the fact that they tend to be even more affluent households. I don't think that's the fault of the smart controller. We have seen savings from the smart controller pre-post. But it was fascinating to me that they both respond really well to weather on their outdoor only use. The smart controller does a really good job of it, and I really thought it might do a better job than homeowners without one. So not good or bad about the smart controllers, but it's very encouraging on both sets of customers to see that incredible response to rain. So let's go to the next slide. So drought restrictions are a big deal everywhere. If you do them, you want to know that something is happening from them. So we looked on this slide, it's kind of busy, there's a lot going on. You've got in the kind of royal blue, you've got our outdoor gallons per household per day. And then that light blue is the reference ETO. And so you see an interesting phenomenon that we tend to see is that people deficit water in the early part of the year. They don't track as close to ETO. And then as it gets hotter and they see their plants getting more stressed, they start tracking more to ETO. And you see a rain event drops the ETO and the consumption, good. Now around the end, 9/29, we got enough rain and our aquifer looked like it was recovering. We made the decision to come out of drought restrictions. Well, maybe that was a little premature because by 10/16 we were back in it. But it gave us an interesting data point that briefly you see that there was a spike up in between those two pink bars. You see when we're out of drought restrictions. There were clearly some customers who went a little crazy on running their irrigation system because they could run it more. And then it started tracking back down again as we were back in drought restrictions. We are still in stage 1, and unless something breaks on the weather, we will be for a while. So we are excited that we're going to get even better data on irrigation frequency and compliance as we message things and as we get into the hotter months of 2021 to help us understand drought impacts even more. So let's go to the next slide. So this, I think, is the most fun graphic that Flume made for us, because this was what were the impact of very specific rules. Could we explain the ups and downs of the indoor usage based on what the local San Antonio events related to COVID were? And essentially the way I explain this to most people is this reflects how much time people spent in their homes. That before the COVID shutdown, and we were about 50 to 55 indoor GPCD, that was kind of situation normal, people coming and going from their homes. Then you see things starting to close down in March, and you see the big spike up where a lot of things were closed down. Non-essential business ordered to close March 23rd, shelter in place order, and things went up. People spent more time at home. And then you see almost just to the day on May 1 in Texas, malls and things were allowed to open at reduced capacity. Dentists, healthcare were allowed to reopen, and we started a decline. Further decline as more things opened. You can see when childcare opened and shelter in place expired. Then you see other events like when the bars closed again at one point when we had a spike, and you see it go up. And then when schools reopen, that seemed to have a significant impact. But we haven't returned to normal, and this tracks with what the community is telling us. Just because schools open doesn't mean all the kids went back to school. A lot of Texan kids are still virtually learning and not back in school. So no, we're not back to quote unquote normal indoor GPCD, but really just a fascinating look at how events matter in how much time people spend at home and therefore what their indoor usage is. So let's go to the next slide. So the last thing I want to talk about is kind of an unexpected benefit that we have really tried to capitalize on from the Flume program, and that is our customer relationships. Every time I talk to somebody else who works in the water utility world, and I say, does anybody ever say to you, I couldn't have used that much water, my house would have floated away, not a chance, I don't trust you, I don't believe you. I'm glad it's not all our customers who say that, but that's the thing, people don't understand how they use water, they don't understand scale. And so this is a common refrain. So we got to a point where we noticed that the people in our programs were feeling more in control. So our customer service department became very interested in Flume. Let's go to the next slide. And we've shown you this before. I want to bring it up again, though, that the customer has this view on their phone, and they can see in almost real time. They use water, they refresh, they can see what happened. And we have a utility view to see the same thing. So when we're trying to sleuth out with the customer, where is all that water going that you don't believe you used? We're seeing the same data. And our customer service department that has escalated complaints, they can see it. So it's not all on conservation. So they use this. It has become such a tool for the I'm glad to say not all customers, but the few that really escalate in their dissatisfaction, that our customer service department has started a loaner program for the Flume. Because if someone's really, really mad and you tell them, I want you to buy this and wait for a rebate on it, you just made them madder. So we've worked with them and said, okay, here's a set of Flumes. People can borrow it free of charge for 2 months. And often that cools the whole thing down, and they often want to keep it at the end of the 2 months. So let's go to the next slide. Also, we can see this effect in social media periodically. If anybody's gone into their own Nextdoor, you may have gone down the rabbit hole of watching the complaints about your utility. It's not fun. I tend to say stay out of my Nextdoor neighborhood thing for the most part. But every once in a while, somebody will say, hey, you got to hop on your Nextdoor thing because people are talking about that Flume program. Somebody actually defended saws. You're serious? Really? This I have to see. So this is one where I went in and did a screenshot. And it started as a chain of the usual suspects complaining about, I couldn't use the water, anybody want to sue, join me in a lawsuit, kind of stuff. And then you see somebody else jump on and say, sometimes they'll offer up our other conservation programs, but in this case, they jumped in and said, hey, you should take advantage of that rebate Saws has on that Flume device. I got one, it was easy. And you see this conversation. It was easy to install. I like it so much I got from my mother-in-law. Make sure you buy it through Saws. And this is great. We love to see a solution that has caught on enough that it's not only us talking about it. And then what I want to end with on the next slide is the recent events in Texas. We had this terrible freeze that was just a mess. People lost water service. We have estimates that as high as 100,000 homes in our market had burst pipes. We'll never know the exact number. We know it's thousands, and our COO thinks it could be as high as 100,000 homes had damage due to this extraordinary record-breaking freeze. If you're wondering, did the Flume help? Yes. The feedback was really good from people that as the water service was coming back on and things were thawing, we heard from customers who had it that they felt a lot better. Instead of running out and looking at their meter every 2 seconds or waiting for the other shoe to drop, waiting for water to start flowing down through their ceiling or wherever, they were just monitoring the Flume instead, and it did quickly catch some leaks for some of those customers. And then, by the way, of course, not a surprise, after the deep freeze was over and this event was over, there was an uptick in Flume sales in San Antonio. So with that, I'll stop and we'll move on to the next section. Thanks, Sarah.
Thank you so much, Karen. And, we are at our closing, but first, I just want to thank you so much for both your presentation and taking the time. As we know, you, of course, have so much to do, especially now as the immediate danger has passed. I know that there's so much going on. So we really appreciate your time and you joining us here. We have a lot of questions and we're going to go ahead and get into those in just a moment. So we'll kind of go through them hopefully individually, and I'll probably be pulling folks back online to answer questions as they come up. One of the biggest questions that came up, and I just kind of want to highlight this map to show you all, what this means when we say we have a lot of data on kind of customers across the country. This is actually a map of where we have Flumes installed kind of across the United States. And as a reminder, many people purchase Flumes, many individuals purchase Flumes online and can and do install it themselves. We sell them on our website. If you go to flumewater.com, you can check it out yourself. They retail for $199. But we also work with a lot of utilities, as Karen kind of just shared there, and we work with utilities across the country who are interested in kind of getting this data, getting access to this data, and advancing some of these benefits to their customers. We do wholesale discounts to utilities, and then often we do cost share element with customers, so customers can get easy access to this. It takes some of the financial burden off the utilities, and ultimately everyone benefits in the end. And we run this in a number of different ways. We've worked with utilities very large, we've worked with utilities very, very small, and we're really flexible in how we roll this out, understanding that every utility is unique and there are different unique challenges in kind of adopting new technology and making things happen. But in the meantime, I just kind of wanted to show you kind of our hotspots, where we're mostly located, where we do have devices. And if you're curious about the amount of Flumes in your area, or if you're curious about the data that we have about your area specifically or your state, please contact us. We're happy to work with you kind of in whatever capacity makes the most sense. And I think all of our contact information is right here. But as we move into questions now, I really appreciate everyone's time. I'm sure we could spend another hour and a half kind of talking about states and various communities. And I think, as I mentioned at the start, at Flume, we believe you really can't manage what you can't measure. So we work really hard to make sure that our data is solid and high quality. I'm going to start answering a few questions. There are so many of them. So let me actually direct one to Karen specifically just before you jump off. Karen, Don asked, is the data from Flume pooled into your CIS system and linked with customers' accounts, or is it housed only on Flume's program? And I figured you might be the best person to answer this.
Yeah, it's we keep it very separate. If there's one thing that is something we just need to be very careful of, is that the Flume data is not going to match the SAWS data, and we tell people that all the time. We don't read every meter on the first and the last day of the month, and we read in CCFs, and they're just unit differences and all kinds of things. So we are very careful to message, and Flume is really supportive, by the way, about being consistent with us. This is not for billing. This is only to help you understand your usage patterns. And so I got to give a good shout out to Flume that when we talk to them and say, if customers call, this is what we need you to say, they do it. And that keeps it from turning into a problem with the data not being exactly the same.
Yeah. Thanks, Karen. And yeah, I really appreciate that. We have all of our support is in-house, and we also kind of make that the same too. Often if customers contact us saying, hey, my bill doesn't match, we say, well, first of all, we need to make it clear that, your utility often is billing on a different cycle than what we're showing you. So keep that in mind. And we work really closely with utilities to make sure that is happening. I want to dive into some of the technical questions that we have. James, can I pull you online? One of the questions that came up is that dishwashers and faucet events are very similar. Can you explain a little bit more about how we distinguish between these?
Yeah, and for the appliance disaggregation, we're still in the learning phase of getting some of these more challenging appliances, such as dishwashers, clothes washers, and faucets. But dishwashers they're very cyclical in nature, and they do look quite a bit different at the 5-second level than a typical faucet does. So it's something that we're actively learning on, but we definitely believe that we're going to be able to disaggregate between the two.
I'll just jump in, and then in past end-use studies, mechanical devices are generally fairly straightforward for being able to disaggregate. When you have this either 5-second or 10-second data, a variety of different approaches have proved successful for being able to separate faucets and dishwashers.
And actually, I want to keep both of you online for the next question, which I think is pretty much somewhat related. Someone asked how accurate our manually labeled events are.
Yeah, and that goes back a little bit to the data sources that we use for manually labeling events. We try to use the most accurate techniques possible, so such as using true ground truth data and utilizing some of the experts that we work with to label that. And then once the algorithm is going, it is labeling itself, and we have seen it be very, very accurate, especially for indoor-outdoor.
Awesome, thanks. Just a flag, I'm noticing this come up a couple of times. We are recording this presentation. We will be sharing both this and the slides following this. Please expect an email in your inbox either later today or early tomorrow. It all depends on how quickly Zoom gets this uploaded onto the cloud. And so we will be sharing this with everyone kind of following this. Karen, there's another question that came up that I think is specific to the pilot. They wanted to know how the group of customers were determined to be part of the pilot for that initial kind of work we did with you before expanding this.
Yeah, great question. We determined which type of customer we wanted to have the answer for, and then picked intentionally people who fit that demographic. So we did guess correctly that this would be appealing to kind of our upper income customers, and we deliberately set parameters of water use patterns and home values and lot sizes to make a selection We offered it to all of them and then randomized from those who said yes, who got it and who stayed in the control group.
Awesome, thanks. Someone asked, and this kind of actually might be a question for multiple people, how customers appear to be responding to the data. So how many leaks are found? Are people fixing the leaks? Are they curtailing any other end use based off of the data they're seeing? I know we see a lot of this kind of on our end, but Karen, you might also have some insight into this as well.
Well, there are things that people, the biggest boon to us is that there are these, I call it the water mysteries, and it's not always a leak. We say leak all the time and that confuses customers, but if you're running your irrigation unintentionally every day, that's not a leak. That's an unintentional use that you didn't understand previously. And also water softeners, where people don't understand they're recharging every day. Those kinds of things, or a stuck valve. We've had ones where like one of the valves was sticking and running with every other zone. And just these really strange things that can happen in homes. Oh, autofills on pools, another problematic thing that's really hard for people to diagnose on their own. And so those kinds of things are becoming aha moments for customers where they now understand it. And they may still need our help to reprogram that irrigation system that they didn't understand as well as they thought they did. But those are the things that we're hearing is oh, I get it now. Okay, thank you. If that helps.
That's super helpful. And then Joe and James, I know that you guys see a lot of this kind of as well. Do you have any thoughts on that?
Yeah, we've actually taken a look at it utility by utility, and we do that analysis for each utility, and it's pretty consistent. About 60 to 70% of people who install a Flume find a leak within the first 30 days. And again, leak, as you said, Karen, is, it's a lot of different things. Like you said, anything from a stuck pool filler to a leaky toilet flapper. Those are typically the types of leaks people find, but still significant. And those are the types of things that actually can turn into a lot of water use if they're not fixed. So.
Totally. And then I actually want to answer the third part of this question. Scott asked, is there a difference in response from customers who receive the device for free versus buying it? I would say yes. And in fact, we actually very much encourage, even with our utility programs, some sort of cost share element. It provides some sort of skin in the game often for customers. If they receive a device for free, it sits in their garage. They don't have any sort of interest in it. We find that even $25 that they pay, and maybe the utility takes on the rest, makes a huge difference in actually getting it in the ground. The benefit too of actually being able to monitor the device the second it's installed is we also know when the device has been delivered, if it's been installed, when it's online immediately. And so that provides also better auditing technology if we're working with utilities to say, hey, you don't have to do a drive-by. You don't need a person from operations or, metering to go out and actually check. We can tell you immediately. And if, we have a customer that hasn't installed it, we can message them, when they sign up, they share their contact information with us. And so we can kind of ensure that you have really high installation rates. And we consistently do have really high installation rates kind of across communities. Let me go ahead and pull up a few other questions. There's just so many in here. I'm sorry, give me just one moment. Wow. Hold on. Is anyone else seeing a question, by the way, that they want to dive into?
I see one. If you don't mind, I'll jump in on the AMI question. Someone's asking, is it a bridge to AMI? A bridge to AMI is exactly how I've described it in San Antonio. We are going to AMI. Our pilot is starting shortly. And I have said to people, eventually we'll get there with AMI, and it'll take 5 years to roll out AMI across 600,000 meters in San Antonio. And it's very different. It is not the same thing. The data detail is different with AMI. It is a thing the customer has to maintain at their house. They got to have Wi-Fi. They got to make sure they monitor their batteries. And so we're having trouble deploying these to the very low income households. We're trying, we're even willing to give them a MiFi to get that data set in our pool of data. But it's not the same thing, but it is a great way to get our customers interested in more data and help the rest of the utility, frankly, get used to looking at it to try to figure out what it means.
Yeah, I would also say too, we work with communities that have AMI. They're actually Round Rock, Texas, a neighbor of yours, has fully deployed AMI. And, once they deployed it, they were having some local need for additional information. I think the data they were receiving was not really detailed enough. And so they kind of installed Flume to gain additional information. But really, I think also the customer facing element was a really key part of that for them. They were really interested in providing the insights to their customers. And so we were able to install Flume on top of that. We're running a program right now. They're actually doing a really active program for Fix a Leak Week to encourage installation, top of mind right now, obviously for many Texans, in order to also encourage kind of greater insight and kind of get those customer service benefits, as well as just kind of expand efficiency programming as well in those communities.
Yeah, I just want to add that, Flume is compatible with any positive displacement meter, whether it's an AMI meter or a traditional positive displacement. So so you could have an AMI system and just like Sarah said, and still use Flume to collect additional higher resolution data, because generally AMI systems are only going to give you 1 hour, maybe 1 minute at best, but certainly not 5 seconds.
Yeah. Joe, there's a question here that I want to make sure we're being responsive to. In some communities, there's sensitivity about letting customers into the meter pit. And I think it's really important we address that. I just want to provide a quick thought, but I also know you work very closely with a number of utilities across communities to kind of manage this and address this concern. As I mentioned, we've got tens of thousands of devices installed around the country. We work very closely with utilities to make sure that they are A, comfortable, and B, understand kind of exactly what Flume does. We are not here to cause any issues with your infrastructure. We understand that. We work very closely with customers to ensure that we are protecting the infrastructure of the meter itself, while also kind of providing these added benefits. And we have never had an issue with a customer installing the device and causing issues. But Joe has also worked with a number of utilities kind of on a variety of spectrum to kind of manage this concern.
Yeah,
Let's find sick meters. We have found sick meters through the deployment of the Flume. That's a fascinating thing when it won't sync with our meter. And then we've gone back and bench tested the meters that it wouldn't sync with. Generally, that meter was sick and we needed to replace it for revenue purposes anyway.
Yeah, we did find a lot of those in SAWs, the 20-plus-year-old meters that were underreporting. And if Flume didn't work, we knew it was a bad meter. So that was a good side benefit that we never expected. But back to the question, different utilities have different tolerances for people touching the meter. And some utilities actually have stuff in their bylaws that say that customers may not touch their meters. So we work very closely with utilities. If any utility is concerned that there's going to be an issue, we're more than happy to give that utility a device so they can bench test it and make sure, that it A, is accurate, and B, is not interfering with any of the infrastructure. And if any of you have questions about that, feel free to contact either Sarah or myself, and we can definitely help you with that. And just one last point, which is, we have tens of thousands of these things installed and are working very closely with utilities, as Sarah said, and we haven't had any issues. And I know, Karen, you haven't had any issues with the devices in the pits, correct?
No, we haven't had any. There's no problem with reading the meter or anything. Customers will find anything to try to create dissension over the bill over. But as I said, the key is everybody speaking from the same page. And so the reason it's worked so well with Flume is that you guys are always supportive of the SAWS meter is your bill. That's what SAWS is going to read to do the bill. So we're saying the same thing to customers, and we can still read the meter. So yes, that's going well. Totally.
And the benefits really often do outweigh some of the initial kind of confusion, or if that even exists. Joe, can you speak a little bit? Someone asked about our homeowners insurance companies work. We do work with them, and I know you work very closely with a number of them. Can you speak to that a little bit?
Yeah, definitely. It's a bit of a complex question because depending on where you live, and which insurance company you have, you could get a very different answer. Some insurance companies do offer discounts for our device, and what I recommend is just check with your insurance company. Even I didn't bother to do that until recently, and I checked with my insurance company and they gave me a discount. So again, the rules are different in every state, and so just check with them. And,
Totally.
and then it's cool because I got a 10% discount. So the discounts range pretty much anywhere from 5 to 10%. So it is worth checking.
Yeah. Someone asked, and I can actually answer this because I run a lot of these programs as well. If someone purchased their Flume on their own outside of a utility program, would it be connected to the utility to provide that very important partnership and an understanding of water use? So the initial answer is no, but I want to add a little bit more kind of context for that. For our utility programs, we have customers purchase their device through a landing page that we set up that is co-branded with the utility. We work very closely with the utility, and that is where customers can get the discount on the device. We usually like to do that up front. It actually encourages people to purchase through the website. And we do this because actually when customers purchase the device, they sign a terms and conditions right there that proactively says, yes, I know that Flume will be sharing my data with the utility, and I am okay with that. And so in that, we are able to share our customer information with the utility, both at the individual level, but also aggregated across communities. If, let's say, you reach out to us and we already have, let's say, a couple hundred devices installed in your community, we are able to share that information in the aggregate for those customers that have already installed the devices. We are, want to protect our customers and their individual information. But that being said, if you were to run a larger program or expand that program, we would then run it in a way that would allow for us to share that information with you. We also constantly have the ability to reach out to our customers that have already purchased and installed devices. And so if it was really important for you to get that information, we could actually very much message current people that have devices installed and find some way to potentially share that information with the customer's kind of approval. But we really, when we set up a utility program, we do so in a way that, everyone knows, hey, I'm purchasing this through a utility kind of discount, and also Flume will be sharing my information with the utility, but we work really hard to make sure that we're protecting the sensitivity of our customers. James, this is a bit of a question for you. There's a question about whether Flume is supported in areas outside of the US, and I know it depends. Can you speak to that a little bit?
Yeah, right now Flume is primarily for the US and Canada.
And then can you actually share a little information as well about any just meter sensitivities that people should be aware of as they're looking at the Flume as well?
Yeah, so Flume is compatible with about 95% of the water meters that are out there. As someone mentioned before, it does require a positive displacement meter, so we do not work on ultrasonic meters. And I did see a lot of questions about the accuracy to the meter. We have done an independent third-party test with the University of Utah that showed that Flume devices are within 1% of the meter reading. So it's very accurate and very accurate on all the meter types as well.
Yeah, I think it was like 99.6% or something. I mean,
yeah.
It was really huge. So that was great. Thank you so much. I'm just trying to see if there's anything else that I can answer immediately. Thank you to Clay, who's been in the background here answering a lot of these questions as well. Let me just see one second. There's a question about kind of comparing, the difference between AMI. Again, can we speak a little bit, and James and Joe, this might be a good question for you guys, about the difference in accuracy for AMI, or not accuracy, but difference in kind of reading capacity for AMI versus Flume?
Well, maybe I could speak to
Peter,
that, since
would
I
love that.
serve on
Thank
the
you.
AWWA metering committees. So AMI, it generally requires the utility to create their own network to transmit the signal from the meter and get it back to the utility. So it's a radio, or they set up a series of antennas that it's their own network. The Flume device uses the existing internet and Wi-Fi within the house. That is a very important distinction between the Flume and traditional AMI systems. So you could have both. I mean, you can have the AMI working, sending a signal, and then the Flume could be attached to that same meter and sending its signal via the internet. I hope that answers the question.
Yes. And I just want to recognize we're actually at now our official end. I think there's just one more question I would love to ask, and then I'm going to thank everyone so much for attending. Um, and Peter, actually, I think this is a great question for you to kind of wrap us out. How does Flume really help with utility demand analysis?
So this is really important. I think there's a number of different ways. From the utility perspective, I mean, Flume is going to give you an idea of the trajectory of demand in real time. Now, you can say, well, maybe it's not a perfect sample, so maybe it's not the exact average volume, but it is the trajectory of your demand across your single-family customer base. And so that is of itself, real time can be very helpful. And then retrospectively, if you're doing, forecasting or analysis, you're trying to figure out how much am I going to use in the future. These are data that are going to be extremely valuable for understanding what demand is going to look like in the future. And then for those of you that are going to look at drought this summer, this is also a device that can be used by customers to help them manage their water use and to understand their water use and even to manage to a water budget or a volume. There's never been a device that's this inexpensive that you could give to customers and help them to understand how much they're using and to manage water in that way. So that's also going to be very important for drought response.
Awesome. Thank you so much. And for those that I know there are a lot of questions here we didn't get a chance to answer. If you're interested, please use these emails and contact us. We're happy to answer any other questions that arise about the device, about what we do, about how we can potentially help you. And for now, I'm going to just be respectful of everyone's time and say thank you so much. And thank you so much for attending.